Telecommunications engineering, or telecoms engineering, is an engineering discipline that brings together all electrical engineering disciplines including computer engineering with systems engineering to enhance telecommunication systems. The work ranges from basic circuit design to strategic mass developments. A telecommunication engineer is responsible for designing and overseeing the installation of telecommunications equipment and facilities, such as complex electronic switching systems, copper wire telephone facilities, fiber optics cabling, IP data systems, terrestrial radio link systems for conventional communications and process information. Telecommunication engineering also overlaps heavily with broadcast engineering. Telecommunication is a diverse field of engineering which is connected to electronics, civil, structural, and electrical engineering. Ultimately, telecom engineers are responsible for providing the method for customers to have telephone and high-speed data services. It helps people who are closely working in political and social fields, as well as accounting and project management. Telecom engineers use a variety of equipment and transport media available from a multitude of manufacturers to design the telecom network infrastructure. The most common media used by wired telecommunications companies today are copper wires, coaxial cable, and fiber optics. Telecommunications engineers use their technical expertise to also provide a range of services and engineering solutions revolving around wireless mode of communication and other information transfer, such as wireless telephony services, radio and satellite communications, internet and broadband technologies. Most of a telecom engineer's work is carried out on a project basis with tight deadlines and well-defined milestones for the delivery of project objectives. Telecommunication engineers are involved across all aspects of service delivery, from carrying out feasibility exercises and determining connectivity to preparing detailed, technical and operational documentation. This often leads to creative solutions to problems that often would have been designed differently without the budget constraints dictated by modern society. In the earlier days of the telecom industry, massive amounts of cable were placed that were never used or have been replaced by modern technology such as fiber optic cable and digital multiplexing techniques. Telecom engineers are also responsible for overseeing the company's records of equipment and facility assets. Their work directly impacts assigning appropriate accounting codes for taxes and maintenance purposes, budgeting and overseeing projects. History. Telecommunication systems are generally designed by telecommunication engineers which sprang from technological improvements in the telegraph industry in the late 19th century and the radio and the telephone industries in the early 20th century. Today, telecommunication is widespread and devices that assist the process, such as the television, radio and telephone, are common in many parts of the world. There are also many networks that connect these devices, including computer networks, public switched telephone network, radio networks, and television networks. Computer communication across the Internet is one of many examples of telecommunication. Telecommunication plays a vital role in the part of world economy, and the telecommunication industry's revenue has been placed at just under 3% of the gross world product. Telegraph and telephone. Samuel Morse independently developed a version of the electrical telegraph that he unsuccessfully demonstrated on the 2nd of September, 1837. Soon after he was joined by Alfred Vail, who developed the register, a telegraph terminal that integrated a logging device for recording messages to paper tape. This was demonstrated successfully over 3 miles on the 6th of January 1838 and eventually over 40 miles between Washington, D.C., and Baltimore on the 24th of May 1844. The patented invention proved lucrative, and by 1851 telegraph lines in the United States spanned over 20,000 miles. The first successful transatlantic telegraph cable was completed on 27 July 1866, allowing transatlantic telecommunication for the first time. Earlier transatlantic cables installed in 1857 and 1858 only operated for a few days or weeks before they failed. The international use of the telegraph has sometimes been dubbed the Victorian Internet. The first commercial telephone services were set up in 1878 and 1879 on both sides of the Atlantic in the cities of New Haven and London. Alexander Graham Bell held the master patent for the telephone that was needed for such services in both countries. The technology grew quickly from this point, with intercity lines being built and telephone exchanges in every major city of the United States by the mid-1880s. Despite this, transatlantic voice communication remained impossible for customers until January 7, 1927, when a connection was established using radio. However, no cable connection existed until TAT-1 was inaugurated on September 25, 1956, providing 36 telephone circuits. In 1880, Bell and co-inventor Charles Sumner Tainter conducted the world's first wireless telephone call via modulated light beams projected by photophones. The scientific principles of their invention would not be utilized for several decades, when they were first deployed in military and fiber optic communications, radio and television over several years. Starting in 1894, the Italian inventor Guglielmo Marconi built the first complete, commercially successful wireless telegraphy system based on airborne electromagnetic waves. In December 1901, he would go on to establish wireless communication between Britain and Newfoundland, earning him the Nobel Prize in Physics in 1909. In 1900, Reginald Fessenden was able to wirelessly transmit a human voice. On March 25, 1925, Scottish inventor John Logie Baird publicly demonstrated the transmission of moving silhouette pictures at the London department store Selfridges. In October 1925, Baird was successful in obtaining moving pictures with halftone shades, which were by most accounts the first true television pictures. This led to a public demonstration of the improved device on 26 January 1926, again at Selfridges. Baird's first devices relied upon the Nitkoff disc and thus became known as the mechanical television. It formed the basis of semi-experimental broadcasts done by the British Broadcasting Corporation beginning September 30, 1929. Satellite. The first U.S. satellite-to-relay communications was Project SCORE in 1958, which used a tape recorder to store and forward voice messages. It was used to send a Christmas greeting to the world from U.S. President Dwight D. Eisenhower. In 1960, NASA launched an Echo satellite. The 100-foot aluminized PET film balloon served as a passive reflector for radio communications. Courier 1B, built by Philco, also launched in 1960, was the world's first active repeater satellite. Satellites these days are used for many applications such as uses in GPS, television, internet and telephone uses. Telstar was the first active, direct relay commercial communications satellite, belonging to AT&T as part of a multinational agreement between AT&T, Bell Telephone Laboratories, NASA, the British General Post Office, and the French National PTT to develop satellite communications. It was launched by NASA from Cape Canaveral on July 10, 1962. The first privately sponsored space launch. Relay 1 was launched on December 13, 1962, and became the first satellite to broadcast across the Pacific on November 22, 1963. The first and historically most important application for communication satellites was in intercontinental long-distance telephony. The fixed public switch telephone network relays telephone calls from landline telephones to an Earth station, where they are then transmitted a receiving satellite dish via a geostationary satellite in Earth orbit. Improvements in submarine communications cables, through the use of fiber optics, caused some decline in the use of satellites for fixed telephony in the late 20th century. But they still exclusively service remote islands such as Ascension Island, St. Helena, Diego Garcia, and Easter Island, where no submarine cables are in service. There are also some continents and some regions of countries where landline telecommunications are rare to non-existent, for example Antarctica, plus large regions of Australia, South America, Africa, northern Canada, China, Russia and Greenland. After commercial long-distance telephone service was established via communication satellites, a host of other commercial telecommunications were also adapted to similar satellites starting in 1979, including mobile satellite phones, satellite radio, satellite television and satellite internet access. The earliest adaptation for most such services occurred in the 1990s as the pricing for commercial satellite transponder channels continued to drop significantly. Computer networks and the Internet. On the 11th of September 1940, George Stibitz was able to transmit problems using teleprinter to his complex number calculator in New York and receive the computed results back at Dartmouth College in New Hampshire. This configuration of a centralized computer or mainframe computer with remote, dumb terminals remained popular throughout the 1950s and into the 1960s. However, it was not until the 1960s that researchers started to investigate packet switching, a technology that allows chunks of data to be sent between different computers without first passing through a centralized mainframe. A 4-node network emerged on 5 December 1969. This network soon became the ARPANET, which by 1981 would consist of 213 nodes. ARPANET's development centered around the request for comment process, and on 7 April 1969, RFC1 was published. This process is important because ARPANET would eventually merge with other networks to form the Internet, and many of the communication protocols that the Internet relies upon today were specified through the request for comment process. In September 1981, RFC 791 introduced the Internet Protocol version 4 and RFC 793 introduced the Transmission Control Protocol, thus creating the TCP/IP protocol that much of the Internet relies upon today. Optical fiber. Optical fiber can be used as a medium for telecommunication and computer networking because it is flexible and can be bundled as cables. It is especially advantageous for long-distance communications, because light propagates through the fiber with little attenuation compared to electrical cables. This allows long distances to be spanned with few repeaters. In 1966, Charles K. Cow and George Hockham proposed optical fibers at STC Laboratories at Harlow, England, when they showed that the losses of 1000 decibels per kilometer in existing glass was due to contaminants, which could potentially be removed. Optical fiber was successfully developed in 1970 by Corning Glass Works, with attenuation low enough for communication purposes. And at the same time, GAAS semiconductor lasers were developed that were compact and therefore suitable for transmitting light through fiber optic cables for long distances. After a period of research starting from 1975, the first commercial fiber optic communications system was developed, which operated at a wavelength of around 0.8 micrometers and used GAAS semiconductor lasers. This first-generation system operated at a bit rate of 45 megabits per second with repeater spacing of up to 10 kilometers. Soon on the 22nd of April 1977, General Telephone and Electronics sent the first live telephone traffic through fiber optics at a 6 Mbit per second throughput in Long Beach, California. The first wide-area network fiber optic cable system in the world seems to have been installed by Rediffusion in Hastings, East Sussex, UK in 1978. The cables were placed in ducting throughout the town, and had over 1,000 subscribers. They were used at that time for the transmission of television channels, not available because of local reception problems. The first transatlantic telephone cable to use optical fiber was TAT-8, based on DSAV-optimized laser amplification technology. It went into operation in 1988. In the late 1990s through 2000, industry promoters, and research companies such as KMI and RHK predicted massive increases in demand for communications bandwidth due to increased use of the Internet and commercialization of various bandwidth-intensive consumer services, such as video on demand. Internet protocol data traffic was increasing exponentially, at a faster rate than integrated circuit complexity had increased under Moore's law. Concepts. Basic elements of a telecommunication system: transmitter that takes information and converts it to a signal for transmission. In electronics and telecommunications, a transmitter or radio transmitter is an electronic device which, with the aid of an antenna, produces radio waves. In addition to their use in broadcasting, transmitters are necessary component parts of many electronic devices that communicate by radio, such as cell phones. Transmission medium over which the signal is transmitted. For example, the transmission medium for sounds is usually air, but solids and liquids may also act as transmission media for sound. Many transmission media are used as communications channel. One of the most common physical medias used in networking is copper wire. Copper wire to carry signals to long distances using relatively low amounts of power. Another example of a physical medium is optical fiber, which has emerged as the most commonly used transmission medium for long-distance communications. Optical fiber is a thin strand of glass that guides light along its length. The absence of immaterial medium in vacuum may also constitute a transmission medium for electromagnetic waves such as light and radio waves. Receiver that receives and converts the signal back into required information. In radio communications, a radio receiver is an electronic device that receives radio waves and converts the information carried by them to a usable form. It is used with an antenna. The information produced by the receiver may be in the form of sound, images or data. Wired communications make use of underground communications cables, electronic signal amplifiers inserted into connecting cables at specified points, and terminal apparatus of various types, depending on the type of wired communications used. Wireless communication involves the transmission of information over a distance without help of wires, cables or any other forms of electrical conductors. Wireless operations permit services, such as long-range communications, that are impossible or impractical to implement with the use of wires. The term is commonly used in the telecommunications industry to refer to telecommunications systems which use some form of energy to transfer information without the use of wires. Information is transferred in this manner over both short and long distances.